Hello and welcome to CS 112's Lesson 16.1 Clock Face. This is part of the University of Idaho dual credit CS 112 class. Alright, so today we're going to be starting our last kind of major project, and this is going to last a couple of lessons. And what we're going to be doing is we're going to be making a rainbow clock, and a rainbow colored clock really is kind of what some people like to call it. As the time ticks, the hands, we're going to have them change color so they match where they're pointing to. This is going to be an analog clock, so for those of you who aren't very good with analog time, you're going to learn a little bit about analog time here. The size of the clock, we're going to make it so that it can be changed as the program is running. We don't want to stop it and start it kind of constantly. We want the user to be able to make it different sizes. In this lesson, we're going to develop the initial code, and we're going to set the dots in the correct position on the face of the clock. And that might sound a little bit simple, but it actually kind of turns out to be kind of challenging, especially if you kind of notice that our clock face with the different dots, we actually have two different size dots, and we want to have them equally dispersed because on a clock they're going to be equally dispersed. So, a couple things just so that you know the overall plan. Our final program, we're going to be able to draw a overall kind of a running rainbow clock. In this lesson, we're going to declare all of the variables that we're going to have, all the global variables at least. Remember, global are used throughout the program, and local are used inside of a specific function, or even inside of a specific for statement. So after that, we're going to write the setup function because we kind of need to set everything up before we can start making stuff work. We're going to write the function for init sizes, and init being initial, and that will help initialize all of the variables the correct way. We're going to write a draw function, which is going to call that initial sizes function. We're going to draw the clock face, and we're going to draw the rainbow colored tick marks with the red starting at the top of the clock and working our way around in that 360 degrees. If you remember from one of the prior lessons, we did the rainbow wheel or the color wheel, and this is actually where that's going to come into effect. So to start off with, we're going to declare some variables, and we're going to declare some global variables. So our global variables, we're going to declare, make this a little bigger. So we're going to make a couple integers and we're going to make a couple floats. So we're going to make some integers, and that's int, and we're going to have cx, center x, cy, center y. So those are the coordinates of your center. That's your center x and your center y respectively. And then we're going to make some more. We're going to, all right, let's make some floats. And float is really important, especially if we're going to have some decimal values. You really probably could make that the center x and the center y be a float value. But the ones that we're going to have as float, we're going to have radius. Radius is going to be a float. We're going to have the clock diameter, clock diam. We're going to have the minute dot size. Notice I use this camel case to kind of help it so I don't have it run on too weird. We're going to do the hour dot size. We're going to have the seconds radius, and what that's going to be is that's going to be the radius, that's going to be the distance that the seconds hand is. We have the minutes radius, and we're going to have the hours radius. And for those of you using processing, we see that everything is lit up in yellow. It's saying, hey, just so you know, none of these are being used. You have these apparently for no reason. We know a little better than that. But for right now, that's kind of what it pops up with. If you're using open processing, it actually probably doesn't show that. So now we're going to continue on. We're going to start doing our setup function. So our setup function, so we're going to do void setup. And in order to resize the frame, we actually use a specific program. And so the first thing that we want to do is we're going to give it a starting size. We're like, all right, we're going to start it at this, and this is going to be something. So I'm going to go size 400, 400. And then there's a specific way to make it so that we can resize it. And so what we use is a dot syntax, and what it is it's surface dot set resizable. Oops, resizable. And we're gonna say true. So what this does is the surface is kind of what we can see, like it's the drawing surface really. And what we're saying is, hey, make it so that yeah we can resize it. Setting it to be able to resizable is an option for us. These are some things that kind of already exist, and it's a little bit nuanced in order to know that, and it just takes a little bit of getting used to the program. So the next thing that we have is color mode. We're going to change our color mode like we did in the color wheel. We want to change this to HSB. And we're going to give it some values. We're going to say, okay, we want 360, we want 100, and we want 100. We want those to be the things that we kind of have. And then we're going to do something else. What we're going to do is we're going to have a frame rate. We're going to change this frame rate. The default is 60. We're going to change this to 1. And so what this does is this draws every second, which hopefully that kind of makes a little sense of why we want to draw every second. You could make it so that you're kind of doing a more continuous clock, but for simplicity's sake, we're going to just kind of keep it here. Okay, so a couple things in the setup that we're kind of looking at is we want to make sure that we keep everything super dynamic. And what I mean by dynamic is that we can easily change it while it's running and it's not going to kind of like freak out on us. But it's still able to make those changes and it's able to scale. And so in our draw procedure, we're going to be calling a procedure to set initial sizes. Instead of using hard coding positions and sizes, we're going to use the center and the radius as different values. All the points are going to be drawn using these references as we did with the last unit. And all of the variables will need to be multiples of the radius, the width, or the height. Because those are things that are kind of not constant, but they're things that we're going to be constantly be able to reference back to and be able to determine quickly. So, oops. Since the setup function is only run once, but the size of the clock can be changed at any point in time, those sizes, we're going to be setting them up inside the draw function. And before we even kind of get to the draw function, we're going to initialize some of our stuff. So we're going to initialize some sizes. And so we're going to go, okay, void init sizes. And so there's a couple things that we need to do. We need to determine the radius of the clock. We need to figure out the length of clock hands. We need to figure out the size of the tick marks. Tick marks for minutes and seconds. We want to be able to determine the diameter of the clock. And we want to be able to figure out the center of the clock. So, whenever we're looking at this, there's a few things, and we kind of start at the beginning. So we want to be able to determine the radius of the clock. So the radius of the clock is kind of a little bit easy. And again, it's one of these kind of almost nuanced type things, but it makes sense whenever you write it out. So we say radius, which we already declared radius up here in this float. So we already know, okay, yep, we already declared radius. So we say radius equals, and there's a term here that we can use, and it's min width, comma, height, divided by 2. Now what this does is this says, okay, we can be able to change the width and the height. We want to select the smallest one. Whichever one is smaller is what we're going to use, and we're going to divide that value by 2. You'll remember radius is from the center to the edge, and so we want it divided by 2. So going with that, we can actually work through quite a few things. So a couple things that we can have is we can figure out the radius of or kind of the length, I guess is the right term, for the different hands. So we want to say, okay, the seconds radius, capital radius, is going to equal the radius times 0.72. And whenever we get into it, it'll make a little more sense on why we're doing this. Then we're going to do the minutes radius equals the radius times 0.60. We want to be able to tell which one's which, and these sizes will kind of help us with that. The hours radius is going to be the radius times 0.5. Okay. We can figure out the diameter of the clock. That one's pretty easy. But we want to make sure that we're not going outside. We want a little bit of a space. And so diameter typically, yes, is radius times 2. But in this case, we're actually going to say that the clock diameter is going to be the radius times 1.8. And again, that's to keep it so that we don't go outside of it. These tick marks, we're going to make the minute dot size. Minute dot size. We're going to make it, again, kind of scale to the size of a clock. We have a big scale. We want kind of these big dots. So we're going to say the radius times 0.015. And we're going to make the hour, I guess I said seconds up here, but minutes and hours. So we want the hour dot size to equal the radius, and we want those ones to be a little bigger. And actually, really, let's just make them so they're significantly big enough that we can tell that they're different. 0.03, so twice as big. Still not very large. That's spelled co-enter. Okay. Next thing that we have is we're going to say Cx equals our width divided by 2. The center of our x is our width divided by 2. That makes sense. And our center y equals our height divided by 2. And hopefully so far, so good. So right now, we should be at the point where we have declared all of our global variables. We've written our setup function. We've written the initialized sizes to initialize variables. And now we can add our void draw. And some of you may have the void draw up here. You may have just instinctually had, okay, void draw. And it's fine either location. And we're going to call init sizes right here. And then we're going to close our draw function. So we kind of have it started, but we're still not to the point where if we were to push the play button, it's not going to show anything. Like it's going to make a screen that's 400 by 400, and we might be able to move it around. So what we need to do is we need to kind of work a little bit more with what we have in order to kind of get closer to what we want. So what we're going to do is we're going to make a couple things. So the first thing that we want to do is we're going to make a variable called float. That's a float, and we're going to call it angle. That kind of makes sense. And we're also going to set the background here. This way it draws over and it's not all kind of gummy. So we're going to say a background of 0. We still have a few things to do. So we still need to draw the clock face. We also need to draw the ticks. So draw the clock face should be a little bit kind of easy for you. We're going to draw a gray clock face, and we're going to make it so that it's either it's going to stay circular, and we're going to make it so that it doesn't kind of stretch out whenever we make it, whenever we increase the screen size, but it should fill in with the screen. So what we're going to do is we're going to draw an ellipse at the center of the screen. So we say, okay, we're going to do ellipse, and we're going to say CX, comma, CY, comma, radius, comma, radius. And you might be thinking, well, didn't you just say that we're going to use whichever one is, oops, radius, that's going to make it too small. Radius times 2. There we go. And actually, really, we can just use clock diameter there. Clock diam, comma, clock diam. Now, if we were to do this, it still probably won't show anything. The reason why is we need to give it a color. And we can just kind of give it a gray color. So I'm going to say, okay, fill, I don't know, 155 should probably do the trick. Let's see here, initialize sizes. So we've already defined what that is. We have a fill, we have an ellipse, and it's going to be at the center. So if I push this play button, now, you should have a gray clock face in the middle of it. And that's it so far. We'll kind of keep going from there. Now this next part, what we're going to be doing is we're going to make it so that then we can have these different ticks so that they're going up by the same amount. And what we're going to use there is we're going to say, okay, we're going to kind of draw these different ticks. We're going to draw enough of them to go all the way around. And whenever you hear me kind of saying we're going to draw something over and over again, hopefully your mind goes to a point where you're like, huh, it'd probably be a lot easier if we make this a for loop. And yeah, it would be a lot easier if we made this a for loop. So we're going to make a for loop, and we're going to use an integer called I. So integer I, we're going to say that equals to 0. And the one thing that you kind of might do is you might say, oh, I'm going to go 0 to 360, or all the way to 360 because that's how much is in a circle. But really, because there's only 60 seconds on a clock, and that's kind of how much we measure by, especially for like minutes and seconds, we actually are only going to go to 60. So we're going to say as long as I is less than 60. And this prevents some issues kind of popping up a little bit later on. Then as we do each one, we kind of think, okay, the way that time works is we increase by 1 each time. And we start a little bracket right there. So next thing that we kind of look at is we say, okay, we're going to set, we can start setting things like color. And remember, we're trying to make it so that we're able to do this color type thing, and we're trying to make it so that it actually scales easily. And there's actually a little trick for this. And the trick is using something called map. And what map is it's a function that we use to convert a value from one range to another. This is the format that it comes out as. It says, okay, we have map value range 1 start, range 1 stop, range 2 start, range 2 stop. And what we're going to do is we're going to make this, and the way that to kind of think about this is the way that like Google Earth or a map works, where you're trying to convert, it's not to scale, obviously. Well, it's to scale, but it's not like full scale model. It's a smaller scale of what we actually see. And so what we say is, all right, 5 inches on the map is actually 25 miles. And from that, you're able to kind of deduce certain pieces of information. So here's kind of an example. So we're going to convert 5 inches on a map to the distance of 25 miles. And so this is what we're starting with. This is what we have. We have 0 to 60 because that's how many seconds are in this time that we're talking in. but a thing on a circle is 360, and so we kind of give it a reference, and this way we don't have to do the math on our own. We just say map, just it's like this, like I want it to go from here to here. So we're going to be using this to help us kind of get this a little better. So what we're going to do is we go, all right, so let's make a fill. So we're going to make a color. And we're going to use that map idea. So we're going to say, okay, we're going to do a map, and we're going to use I. And then we're going to go from 0 to 60, because that's our kind of the range that we're using. But it needs to fill from 0 to 360. So I close that, oops, and I'm going to put in the 100s here. Shouldn't necessarily be necessary, but it's good to have just in case someone messes with something at some point in time. And then what we need to do is we need to start figuring out the angle. And angle is going to use much the same thing. Angle we already defined. We started defining it at the very beginning. We said it's going to be a float. And what we're going to say is we're going to say, okay, angle is going to equal, it's going to equal the map value that we get when we go for I, and the scale goes from 0 to 60, and it goes, and it's kind of referred to from 0 to 2 times pi. Now, if we just do this, it's actually going to have our clock shifted. It's going to be turned. And so what we need to do is we actually need to subtract pi over 2 in order for it to kind of have itself upright and have it in the direction that we want it. The next thing that we do inside this for loop is we want to draw the ellipses. So we're going to draw an ellipse, and where we want these to be drawn is not the center. We want it to be kind of offset a little bit. And we did this before, and so this kind of bit of program might look, or this math might look a little similar. So we do the center x plus the seconds radius times cosine of angle. And as you maybe guess, we're going to do cy plus seconds radius times sine of angle. And what we can do here is we can say, all right, we're going to do the minutes radius, or no, minute dot size, sorry. Minute dot size. And put a semicolon. So now if I go and push the play button, I have these little dots that go around and they kind of follow like the color scheme. But this still isn't quite 100% there. If you look at this, it'd be hard to like look at this and be like, oh, it's 345. Why? Because you can't see the ones, like the 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that you can normally see. So we need to add those dots in there. And there's kind of two ways of going about it. The way that I kind of like is I'm just kind of draw it over the top of them. So if I say if, and what we use for this is a modulus function. So if I %5, so if I divided by 5, we want to say if that is 0, we want to do a certain thing, and this is that Boolean statement. So if it's equal to 0, we want it to do the hour dot size. Oops. But it's not just that. We instead actually go Control C, Control V. And instead of minute, we change it to hour. And instead of minute, we draw it to hour. Now, in all reality, this isn't the most efficient coding. The reason why is we draw the circle and then we draw the other circle. And so what we might do instead is we might say, all right, else draw this. Oops, Control X that. So now if we draw this, it draws the big circles, and it's not drawing it on top of. And so this is actually technically more efficient because you're not drawing over the same spot twice. And you're doing a kind of a check. So that actually kind of, for the most part, concludes what we're going for. What you are going to accomplish, and actually I believe we accomplished all of this already, but take your time, make sure that you're able to get all of this. You should have already initialized the global variables, set up the size, color, mode, and frame rate, and the resizable function, included that initializing sizes function to be called from draw. We drew the clock face and the dots. We started the tick marks at the top with the red, and so the only thing that you need to go in and do is you probably need to go in and comment on these. Go ahead and listen through this again if you're not sure what something does. Submit this however your teacher has you kind of doing it. If you're using open processing, there may be some issues with that scalability factor. Don't worry so much about that. Just try and make sure you get this programming down because we're going to be using it in the next lesson. So as always, happy coding.